Hi, my name is Manish Gupta, and in this video, I'm going to talk about this interesting topic of, can humans learn from debates between LLMs? So if you have LLMs, they're debating with each other. Can a human observer learn or get answers to their questions through these debates? Right? This is based on an ICML, on a paper that won ICML 2024 Best Paper Award. Okay, so let's basically get started with the paper that I'm talking about. And the question is that can small language models and humans sort of learn something from these LLM debates? Specifically, we are interested in machine reading comprehension. So essentially, consider this data set, which is question answering with long input texts. Yes, data set called as quality data set. Well, this data set basically has a median length of 7,000 tokens in the passages, and then there are questions based on that. There are two options, A and B, typically. Okay. So in these kinds of data sets, the idea is that the small language models or the humans are not going to be shown those long texts at all, but they're still going to be asked questions based on that text. And the idea is that based on conversations or debates that are happening between large language models, they must be able to figure out what is the right answer. Okay. So for example, look at this. They're based on Gutenberg stories, Project Gutenberg stories. So here's the Gutenberg story, and these small language models or humans called as non-experts in general can be shown questions of this kind. How did Parks end up on Morgan's planet? Now, of course, this is basically based on some story, so there's no good answer to it. The two options: he was sent on a scouting mission, or his rocket crashed there. Right, one of the two options is correct. So the LLM models, the LLM experts basically can read the passage and share snippets, but the judge, the human judge or non-experts, the small language model non-experts basically has not read the passage. So they don't have any knowledge about the particular context of the story. Okay. So that's that. So that's the setting. Expert models can access the text from the Project Gutenberg story, science fiction story, and argue for a specific answer. So the idea is that large language models, or these expert models, after reading the story, they argue for the correct answer or the incorrect answer. They can argue either way, right? So there will be one LLM which can argue for the correct answer, the other LLM arguing for the wrong answer. Um, and they have to somehow convince the observer judge or the non-expert small language model or a human, right? So there are multiple names given to this observer judge non-expert. It could be a small language model or a human, so as to choose the right answer. Okay. Or the wrong answer. So basically, there is one LLM which is trying to debate towards the right answer, the other LLM which is of the opinion corresponding to the wrong answer. So these weaker or non-expert judges and humans cannot access the underlying text, but they can evaluate the arguments and choose an answer. Now, human judges basically, when they choose the answer, but they can also provide confidence scores. So they can also tell how confident they are about the answer after watching the debate and so on. Okay. In fact, not just debate, they actually try out three different mechanisms: debate, interactive debate, and consultancy. So they are also depicted here. There is a debate, interactive debate, and consultancy here, right? So what are these three different protocols? So in a debate, just like a typical debate protocol, there are two expert LLMs. They're simultaneously presenting arguments for a number of rounds. They actually fix it to 3 rounds. So they work with 3 rounds. So that's what this debate protocol is all about. Okay. Interactive debate basically also means that the judge is not passive, or the person who is trying to human or the small language model, they're not passive. They may ask clarifying questions after each round, right? And consultancy basically means that there is only one expert LLM. There is no debate at all. So there are no two LLMs. There is only one expert LLM. A single expert basically argues for one of the two answers while the judge asks the questions. Right. So essentially, it could be passive consultancy or interactive consultancy. So judge can ask questions or not. But basically, a single expert argues for one of the two answers. A single expert could argue for the correct answer or for the wrong answer, right? But the judge has to somehow look at the responses from the single expert LLM and make the right guess. Okay. Experts, when they, of course, experts, they have access to the story, but they can also they have access to a quotation tool to present the quotes from the text in the tags. So essentially, when they come up with responses, they can also put out these quotes: we quote or you quote. We quote is verified quote, you is unverified quote. So LLMs are of course LLMs. So basically, when they generate stuff, they may or may not generate the accurate strings as it is from the story. So verified quote is exact matching string. Okay. And of course, the LLMs have been told, expert LLMs have been told to not generate unverified codes, but they still end up sometimes generating unverified codes. Okay. All of these large language models, whether they are consultants or debaters, so consultants are the guys, consultants are the guys who participate in consultancy, debaters participate in debate or interactive debate. They have been restricted in terms of how much they can speak or process, right? So basically, consultants can provide 300 words per argument, and debaters are restricted to 150 words per argument. Okay. So this paper experiments with 5 different kinds of debaters or consultants: GPT-4 Turbo, GPT 3.5 Turbo, Claude, 2 Claude models, and Mixtro. Right. Now, when generating a response, these models, these expert models, can actually generate using one of the two approaches: best of n or critique and refinement approach. So best of n approach basically means that you basically sample n different samples, you come up with n different responses, and then GPT-4 Turbo is used as the preference models. GPT-4 Turbo sort of chooses which one is the right one, and that's or best one, and then it outputs that response to the non-expert or the human, right? Critique and refinement actually has an extra model called critique. So there's another model to produce n critiques, and then a preference model grades these n critiques, and the most helpful one is basically used to refine the answer further, refine the answer from the expert LLM further. Okay, so here are some examples. Now, a little bit fun time. So essentially, just some examples to show how these debates look like. So there's a question: what characteristics best describe Captain Lud in this in the present part of the story? And then the two options could be jolly, excited, and tired, or tired, defeated, and confused. So debater A basically chooses the first topic, and then they support that one. Debater B chooses the second answer, and then they support for that one, right? And as you can see, debater A is trying to push the judge or the non-expert to believe that, well, characteristics are jolly, excited, and tired. So basically, it's going to talk about excited and tired and so on and so forth. These green ones are basically things that are highlighted from the story, taken from the story as it is. So they're the verified quotes in that sense, right? And then the human expert is basically told after 3 rounds, only 2 rounds are shown here, one round and second round, similarly from debater B. But after 3 rounds, basically the human judge is asked, what do you feel now? Which is the answer, A or B, right? So that's that. Now here are some examples. Here are the prompts basically which are used to generate these things. So there is a debater prompt. So this is the prompt which is basically used by the expert LLM when you're doing debate, and this is the prompt that is used by the expert LLM when they're doing consultancy. Okay, on the right side. So, of course, you can pause the video and read through it. It's interesting. But some things to notice: essentially, the expert debater is basically told that you are an expert debater, and it's told the task nicely. It's basically also told that you should not overdo the thing, so you should remain within the word limit. It's also told to think. So essentially, it's basically told to think enough before actually creating the argument. So this is the argument that is created and then put out to as argument in the debate. Um, and then it's basically also told to use the codes, and then verified codes, unverified codes, what they are, judgment criteria. It's also told that verified codes are super important, deductions for unverified codes and repeating arguments, and so on. So it's basically told what a good debate really is all about, right? And then it's basically said, here is the question, and here is your defending answer, opposing answer, and so on. So, of course, when you do multiple rounds in the debate, it's also given the response given by the other debater, right? So essentially, that's that. And it's basically then fed the story and the transcript. And then it's given a new argument request that yes, you have to come up with a new argument and so on. Now the details are not here, so you can actually read the paper about what this new argument request is all about. And then it's basically asked to generate the next response in the debate. Similar stuff also happens in consultant, but consultant essentially does not have any other debater. So it's basically slightly different, but more or less similar kinds of things for the consultant prompt also. Now the non-experts or the judges basically try to make sense of the arguments that are going on in the debate or in the consultancy, and therefore come up with a good conclusion. So then, of course, the judge is basically asked. The task is to come up with a good conclusion. So essentially, here it is essentially told, think about strength and weaknesses of each debater arguments, and then and whether you trust them or not, and then tell us which answer do you think is correct. It of course is given both the options and the question. It of course is not given the story, so it does not know the story, but it basically has the entire transcript of the entire arguments that have gone ahead, gone on in the debate. Similarly, the consultancy judge prompt essentially is very similar, except that it does not really have it does not have like two experts. It just has basically one expert LLM giving it various arguments about about either of the alternatives A or B. Okay, A or B. Okay. So here's an example debate and judgment. So the question is this: who is Tina and what role does she play in chapter 1 and chapter 2? Okay. And there could be two answers. Tina is Eddie's friend and neighbor. She accompanies him on a prospective hike. They don't find any trace of radioactivity, but still enjoy the lunch together. Option B could be, Tina is Eddie's friend and neighbor. She accompanies Eddie on a hike through the hills behind the college where he teaches her about isotopes and so on. Okay. So the correct answer is A. Now debater A and debater B, as you see, the two LLMs, this is the expert one, this is expert two. They're both fighting with each other, coming up with various interesting arguments, right? So this is round one, this is round two, and this is round three. After 3 rounds are done, human is asked, hey, what do you think? What do you believe, right? All the green ones are the ones which are highlighted ones are the ones, are the arguments, verified quotes basically from the story. Okay. So you can again pause the video to see the arguments. They're actually fun to read. But finally, basically, human judge says that it seems that Tina accompanies Eddie on a prospective hike. So basically, it comes up with some thinking and some reasoning, and then finally says, the topic on the hike seems to be around uranium atoms specifically rather than radioisotopes. Therefore, it comes up with an answer A, and the confidence is 85%. Okay. So, all of these experiments are good, but what do we learn from this, right? So let's see what works better, debaters or consultants, right? So this plot actually says a lot. So let's look at the plot. So you have all the five judges here. Four of those are LLMs, four of those are small language models, and then this one is basically a human, right? Well, they are not really small language models, but they are weaker language models. Let's call it that way. Models which have not seen the story text as such, right? Even human has not seen the story text as such, right? So what you see is the judge accuracy. So one thing that is sort of obvious from this one is that yes, GPT-4 Turbo is awesome. So essentially it gives you better results, but human is better. So human actually is better compared to still others who have not seen the story text and trying to make sense out of LLM debates in that sense. Okay. Now, what is also interesting is to see that, I mean, typically, whatever with the protocol, whether it is consultancy or debate or interactive debate, compared to a naive human, debate, consultancy, interactive debate, all of them help. Typically, consultancy does not help as much. So you see the golden bar or this bar is basically lower compared to the green bar. So typically, consultancy is not as good as debate. Okay. Now there are two other baselines: the naive baseline and the expert baseline. What are those? Or rather, expert is more like a skyline, and naive is more like a baseline, or expert is more like a top line in that sense. Okay. So naive judge basically is a judge which is presented only the question and possibly answers and also the two options, right, to a non-expert model. So it's not given the story, it's not given any debate arguments and so on. What is an expert judge? Expert judge is basically who is given the entire story. Basically, a judge it's a non-expert judge, but it's given the entire full text to demonstrate a reasonable upper bound. So that's the reasonable upper bound that you see here. So these gray boxes essentially are upper bounds because they have access to the story. Of course, they can do better. Okay. So how do you make judgments here? How do you essentially evaluate these things, right? So one thing to care about is win rate. So basically, a large language model can be very happy if it is able to persuade the judge or these non-experts about its answer options. So if a large language model, if a debater chose to basically debate for option A, it is very happy, it wins basically, or it is persuasive enough. It basically, if the expert judge, if the non-expert judge basically ended up listening to it and favoring the option that it spoke for. Right. So, and accordingly, one can actually compute ELO ratings amongst these LLMs, saying that, hey, this LLM was able to defeat other LLMs because the judge actually listened to this particular LLM much more than the other debater. Okay. But then what also matters is judge accuracy. So in the sense that, of course, this LLM might be very happy about making the judge feel that it could make him or her listen, right? But at the same time, this LLM should also be able to so what is the judge accuracy, right? So overall, what we want finally is that these judges who do not have access to the full information should be able to obtain very high accuracy on the end task, on the machine reading comprehension task. So judge accuracy is that. I mean, So, how many times the judges were able to accurately come up with the right answer choice. Right? So some of the insights are as follows. Debate typically helps LM judges answer hard questions better than consultancy, as you already discussed. What is also not shown here is that arguing for the correct answer provides an advantage to debaters. So a debater is more persuasive or more successful if it is arguing for the correct answer. Now that's sort of obvious in hindsight, but that's interesting to find out using these LLM agents as well, right? And the interesting part is this advantage increases with persuasiveness. So the idea is that if there are better LLMs which are persuasive enough, they can actually generate persuasive text. Then if they are arguing for the correct answer, then they are way well off compared to not so good LLMs still trying to argue for the correct answer, or awesome LLMs but arguing for the wrong answer, right? Higher aggregate ELO rating leads to higher judge accuracy. So the point is that if the LLM is actually more persuasive, and that is why it got a higher ELO rating, it basically also leads to higher judge accuracy. And the way they compute this is by actually running copies of the same model. So they basically ask the same model to be debater A and debater B, and then they fight with each other in that senses. And what they find is that typically if this debater has a high ELO rating, the judge accuracy is also higher in that senses. What is interesting is, though, that higher consultation persuasiveness leads to worse accuracy. So that's a little odd, but what they found is that if you're not doing debate, if you're doing consultation, and in consultation mode, of course, basically the consultant can pick A or B in the sense right or the wrong answer, right? And try to argue for that. Now, the idea is that if the consultant is skillful in the sense that it can persuade the judge nicely, then it can actually persuade it for the wrong answer also, right? And that is why it leads to worse accuracy in that senses. Okay, more capable judges are better at identifying correct arguments across all debaters' strengths. So basically, it doesn't matter what debate is going on between these, or rather, what is the strength of these debaters. If I'm a capable judge, then I can basically try to understand what they are trying to say and make sense of it, whether they are good judges, good LLMs, or not so persuasive LLMs. Okay. Now that's basically when you experiment with non-expert LLMs, non-expert language models. But what happens when you use humans as judges? Right? When you use humans as judges, observations are pretty similar. Debate protocols actually lead to higher accuracy compared to consultant protocols. So consultant is not as good. Interactive debate and debate are much better than consultant guy. Right? So last two bars are actually much better than the the third last bar. Right? Highly confident debate judgments are reliable. So, of course, it's not shown here, but the idea is that humans were also asked to provide a confidence, how much confident they are about a particular answer. So whenever they gave a confidence score of more than, say, 0.7, most of those answers were actually accurate, right? LM debaters are the bottleneck. So basically, when human judges fail, why do they fail, right? Why do they come up with wrong answers? And that's super important to know, because if you're basically trying to be a student and trying to listen to people arguing with each other and trying to make sense out of it, it's super important to have very good accuracy, right? So what leads to poor judge accuracy, right? What leads to errors? So error analysis basically tells that LLM debaters are the bottleneck for higher judge accuracy. So is that these LLM debaters who are debating, they were coming up with weak arguments for the correct answer. The correct debater was not arguing enough. They were basically coming up with weak arguments due to probably poor choice of the quotes. They were not able to rightly choose the quotes so as to be able to come up with the right answer, right? So of course, more work can be done so as to choose those quotes appropriately, so as to essentially reduce the confusion for the judge. And of course, it has to be relevant to the question being asked and to make a good choice between the two answers. So more work there can possibly help improve the effectiveness of these learning from debates kind of a scenario. Okay. So in summary, in this video, I talked about a very interesting topic where not literally small language models, but let's call it non-expert models, and human experts, human non-experts. So both of them are non-experts. Human non-experts and language model non-experts can get better by listening to debates between LLMs. And that's interesting because as these LLMs get stronger and stronger, and they've seen much more text than humans, it's quite possible that humans have not seen that text, but LLMs have seen that text. And then can humans make sense out of these LLMs talking to each other? I think that's a very interesting paradigm where humans might actually need to work in various situations in the future. Okay. Debates are better than consultation. So basically, just debating LLMs are actually better than just one LLM talking to you and helping you find the right answer. Especially when that consultant LLM actually is trying to consult in an adversarial negative answer direction, wrong answer direction. Okay. So that's it for this video. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.